I hope everyone's having a good time enjoying MoneyDance. Um, I have a talk today on liquidity pool models in DeFi AMM products. For context, I'll give a bit of an intro for myself, but I'm Jazear. I think the most famous thing I've done is some work on Thorchain, which I'll get into in just a minute. Let me just share my screen here. And boom. Yeah, here we go. A comparison of liquidity pool models in DeFi AMM products. So I'm Jazear. As I mentioned, I've done some work on Thorchain, but prior to that, I studied computer science and economics at Yale, did a brief stint as a product manager at Microsoft, a data analyst at Madrone, which was a hedge fund consultancy that had position level data on a bunch of trades from different equities, hedge funds traders, and we combine them to create models that help them trade on things like sizing or position or frequency, things like that. Gigster as a technical product manager, where I worked with a lot of really great Fortune 500s in a team of really exceptional people in a freelance network. Then became director of engineering at Swish, which was another development agency. And we had a couple of interesting clients in the blockchain space, one of which was Cosmos, where I was blockchain architect for Peggy, a Cosmos Ethereum bridge that we got an ICF grant from the Interchain Foundation. And also at Thorchain. Thorchain was another client where I did a lot of the early work on the token design and infrastructure. Although I just want to be clear, Cosmos obviously has a really, really large network. And Thorchain likewise is run by an anonymous horde. So I did a bit, and I have a bunch of founders tokens, and I'm really enjoying ChaosNet, but that project has been pushed by so many different people. So all of that stuff that I mentioned in the past leads me to SiftChain, which is an omni-chain decentralized exchange on the Cosmos SDK. We call it omni-chain as opposed to cross-chain to just really signify that we're trying to get as many chains as we can to be connected. I think most cross-chain projects will call out one or two blockchains they want to connect to. There are a couple of projects like a chain bridge, which will call out maybe 4 or 5, or a Rosetta, which will call out 6 or 8 or something like that. But we're going for, I'd say, 20 to 25 at least, plus open sourcing schematics to make it easy to add other blockchains as needed. And we really want as a goal for the company and the blockchain to make it so that adding cross-chain liquidity as a tool for your blockchain is as essential as adding a block explorer or a wallet integration. And we do use Thorchain as a reference implementation. I'm very proud of the work that the Thorchain team has done, and I think a lot of that should be reused here for SiftChain. Actually, Sif is Thor's wife in Norse mythology, so there's a lot of tie-in there. SiftChain also has a hybrid order book and liquidity pool model, so you can trade on liquidity pools as you normally would, but you can also trade with limit orders, and so we think we've got the best of both worlds there. And then finally, SiftChain has SiftDAO. So we always say internally that the core team for SiftChain is temporarily stewarding SiftChain, but ultimately the protocol is actually owned by the community and the DAO. We intend to turn over as much of the protocol as we can until we've entirely turned it over to a DAO like the Synthetics or Compound model. I think the difference between our model and their models is that we want to turn over the protocol as soon as we can, or to start it as soon as we can, and then slowly turn over capacities. So, we've communicated in the Telegram group what exactly needs to be done to run blockchain protocol in our minds. So there's development work, but there's also things like legal and strategy and financial engineering and so forth. And as we evaluate the DAO's work and the community's work, we'll be able to slowly turn over functionality from the core team to the DAO, and we'll give the DAO some amount of money at immediately after the token sale to make sure they can start acting autonomously and separately from from the main core team, and they can invest in things that we haven't necessarily invested in. So That's a bit about me and my background and SiftChain, but I want to talk a bit about how we've been thinking about liquidity pools. We'll start at a relatively high and wide scope, and then we'll just narrow ourselves in over time. So the first question here is just how do markets settle orders, right? You've got a group of buyers and a group of sellers. How do you make sure that the buyers and sellers can exchange goods? Well, there are three main ways to do that. One is batch trading, which is probably something that's not as familiar to people, where orders are placed on either side of the market price and executed against each other in batches. So this has really low volatility because there doesn't need to be a continuous execution of orders, and thus, if someone makes a really, really high slippage trade that would cause high slippage in an order book model, that trade can just be executed against other trades that are on the other side of that price in the other direction, and you'd end up just having a relatively stable change of a movement of price. This is really helpful for some equities and commodities markets where the goal is to have a pretty stable price, but for something like for I'd say most models really where you're trying to build in derivatives and so forth, batch trading just isn't that useful. Then there's limit orders, which I'm sure everyone's familiar with, where you've got a specific price entry and exit, which you do for batch for batch orders, but the orders are executed continuously, and so the time at which you place your order and the amount that you place your order for some alternative architectures, those actually impact when the order is traded is executed, and they're all executed individually. This causes irregular and unpredictable slippage. You don't really know what's on, like when your trade will be order will be executed, and when it does happen, you don't know what other trades, what other orders you'll be executed against. And so as you can see here, there's really, really high slippage for the buy side in this example, in this diagram. There's not as much slippage on the sell side. That's why, or one of the reasons why it hasn't taken off for decentralized exchanges, although that will change over time. And instead, decentralized exchanges have adopted liquidity pools, which use automated market makers. Again, everyone's probably really familiar with this, but to reiterate, the slippage is much more predictable because they use some standard model that calculates slippage. But the con here is that you can execute trades or swaps only at the market price. You can't really specify a price entry or exit. As we mentioned, protocols like SiftChain or Serum try to give the best of both worlds. But for this talk, we're going to focus on the liquidity pool model. So liquidity pools on blockchains are comprised of two subsystems. You've got a validator subsystem and a liquidity provider subsystem. And agents in both of these systems are able to earn rewards through staking on the validator side and by providing liquidity on the liquidity pool side. So this is something that I think a lot of developers don't think as much about. But for someone who's worked on a protocol like Thorchain or SiftChain, we think about a lot. The issue with the Ethereum side is that all of the Ethereum AMM products work on top of the Ethereum blockchain, which has miners instead of validators, and those miners do general purpose computation. So people don't think as much about the fact that a validator or a miner is choosing whether to mine with their ETH, with their capital, or to use that capital on Uniswap, because the capital that's used for mining can be in a currency other than Ethereum. But technically, they are making that decision. It's a lot more obvious when you're in a proof of stake system where you're actually staking the same token that you could be providing for liquidity in a liquidity pool. And so in order to maintain system stability and ensure reasonable function of both the validator subsystem and the liquidity provider subsystem, you have to make sure that the return on investment incurred by agents in either subsystem don't outweigh each other. So there are a number of ways to try to do this, but as it stands right now, a proof of stake system like say Cosmos would not really work very well to have, say, Atom support both liquidity providing and validators, unless some change was made to, say, the Cosmos hub. We've made a change like that for Thorchain in what's called an incentive pendulum, and we're thinking about this from the ground up again for SiftChain. So to talk a bit about the validator subsystem, I won't go through every single module here, but basically you've got tokens that can move in and out of the circulating supply as validators add or remove them from their staking. They can also be slashed, and then there's some minting rule. And these are all things that governance can potentially modify. And they would do so, again, to make sure that we have roughly equal returns for validators and also for liquidity providers. The liquidity provider subsystem is a little simpler to think about. You can add or remove liquidity to different token pools, and you can also swap different tokens as well. And so there's got to be some kind of rebalancing policy where you have the revenues from the liquidity provider system for any particular period of time, which are primarily driven by a liquidity fee policy and by swapping activity, and also funds that are available for liquidity providing. And this all needs to be rebalanced against the minting policy, the slashing rate, and then funds that are available in the staking side for validators. But again, for the purposes of this talk, we're going to assume that the rebalancing policy is driven primarily by the liquidity provider subsystem. So if you think about it, when people are making these trades and they're executing swaps on a liquidity provider system, a liquidity pool system, that's the core of the product. The validators are earning revenue only because they support liquidity pools. And so it does make sense that you'd expect more volatility, and there'd be a lot more factors that play from external markets for liquidity pools than for validators. And so that'll just make the rest of this talk simpler to give. Okay, so we are going to talk now a bit about the Xyk model. Here in this graph, you can see that K is some constant, which is equal to X times Y. And X, the capital X here, is all of the supply of token X, whereas capital Y is the supply of all of token Y. And so as a trader trades, they move along the curve. As liquidity is added or removed from a liquidity pool, you move along the purple or blue lines. So if you're removing liquidity, then you move along the purple line, where the curve gets a little bit steeper on both sides, and thus there will be a little bit extra slippage on either trade. Whereas on the opposite direction, you get less because the liquidity has been added. And you can actually see here we can derive a bit about delta K from delta Y or delta X. Just a quick note here, when we talk about burning here, we're only talking about withdrawing tokens as opposed to removing them from circulating supply. So this is the basic Xyk model that a lot of liquidity providers or liquidity pool products use as their default. Here's the way that this curve works for a canonical representation of Xyk, where there are no fees. So again, here, if you see someone make a trade, they go say down down Y, as in they're removing Y from the liquidity pool, lowercase y, but they're adding lowercase x to the liquidity pool. So they end up moving down and then to the right on those two blue lines. And so you may start with XY, capital X, capital Y in the liquidity pool. And then as you move along the curve, you end up with capital X plus lowercase x, where lowercase x is the amount of liquidity that's been added by the swapper. And you remove a lowercase y, which is the amount of liquidity on the other side for the other token that's been removed. And so a lot of this talk from here will be on figuring out what that lowercase y is. How much can a swapper expect to take out of the liquidity pool for the amount of lowercase x that they provide? So here, we've just shown that lowercase y and what it equals for an automated market maker with no fees. And any trader or swapper or arbitrage treasurer or anyone else is going to look at that basic formula if they were working with an automatic market maker with no fees. But we can look at something like Uniswap with a slight change where they've now got Phi. And here there's Phi is a flat fee. So you can imagine for, say, Uniswap with a 0.3% fee, the swapper here is getting 1 minus that small fee, and you multiply that by the original term that we had on the right, in the lower right corner here. And so there's not a whole lot that's really gnarly about this. I think this is something that a lot of traders can get behind, but it's not necessarily the optimal solution. We've seen a lot of sandwich attacks from Uniswap in its early days, which has since been rectified with some of the changes it's made, but those are primarily technical changes. They aren't really crypto economic changes, at least as of yet. And so, another model that's been proposed is the Thorchain model. And so you can see here between the original no fee model and the Thorchain model, we've got a dynamic slip-based fee. And so that term on the lower right changes. Here, the way it works is the more of a token you buy, or some of the more liquidity you add on the lowercase x side, the higher slippage you're going to incur, and that's the lower amount of lowercase y you'll get. And so this is helpful because if someone wants to demand a large amount of liquidity from the pool, they have to pay incrementally for each unit of liquidity that they get. I won't belabor the point too much. I think the Thorchain materials have done a really good job for that. I just want to point out that these terms are, the difference between, say, Uniswap and Thorchain are really not that different. We've got two different products here, each with substantial market caps and teams and so forth that advertise themselves as having different philosophies. But from a crypto economic perspective, they're very similar. The lines of code to implement these two fees are, not very different at all. In fact, you could actually determine what a flat fee would be like, or for any arbitrary, Thorchain swap by just comparing what that fee would be, in terms of lowercase and uppercase x. And it's really not that complicated. So, anyone who's trying to decide, say, which will definitely be something of interest as Thorchain launches Ethereum swaps. Hey, should I execute this trade on Ethereum on Thorchain, or should I execute it on Uniswap? You could do a really basic calculation to figure out, how the fees compare. And likewise, as a liquidity provider, you can think about how much extra liquidity you might get from one product or the other. Again, the formulas are extremely simple, despite the fact that the teams are quite separate and theoretically have different models. So, from a crypto economics perspective, you can do a lot more interesting things than just what we see here. So with Thorchain and Balancer, if you combine the two, you could end up with a slip-based fee with virtual depth. And again, you can see here, we haven't really added that much. The Thorchain model here is just getting a couple extra constant terms, which are the amount of virtual depth that you're going to add to the X and Y pools. So, I'm not aware of any product that actually does this combination of Thorchain and Balancer on the market. But if one were to exist, you can see, again, the liquidity pool formula would not be that different. The lowercase a and b here really just are multipliers that you can use to add artificial liquidity on either side of the pool. And so if we were to generalize this, we would just say that the y, the lowercase y, that is given to a swapper is some function of the lowercase x, the amount of liquidity that they've added to the system, and also the total supply of the two tokens. And so then the question is, how do we determine that F, right? We've seen what Uniswap does, we've seen what Thorchain has done, but is there some way that we can think about it more broadly for the ideal liquidity pool system? Well, we can discuss some system constraints. So one of the constraints that we see is that some value needs to be given to the liquidity providers. And so on that second line here, we have some value that basically shows on the left side of the inequality, which is like the amount that is sort of retained by the swapper. There should be some that should be competitively compared to the original amount that was in the pools. And we want to do that because the liquidity providers deserve to get some revenue for what they've provided. Otherwise, they're just not incentivized to provide liquidity, and the system is not stable. Another thing that we want to point out here is that there should be no payout given to non-action. So if lowercase x is 0, then the payout for the swapper should be 0. And then a third bit would be that the limit of the realized price should get towards the spot price. And so these are things that may seem obvious, but they're the first of many system constraints that we would want for any system. And if you're going again with a sort of broad-based complexity of systems analysis, you would want to spec out all of the different options using these as boundaries. But there's so much beyond that. So when we think again about the validator subsystem and the liquidity provider subsystem, there are a lot of different variables that you'd want to consider. And I mentioned a few here, say for the validator, like the inflation that's being provided. And there's something like percentage of tokens staked or delegation rates. Actually, we ended up not even having delegation in Thorchain because it was so complicated to get that right. There's also a benefit for anonymity in that if you delegate, then you're kind of incentivizing the validators to reveal a bit of information about themselves, which is not ideal. But even still, to purely understand what the crypto-economic effects of your validator policies are and the validators' commission rates and so forth, that does add a lot of complexity. But there are also things like, say, the circulating supply, the number of validators, the block rewards. There's so much here. Let's say the target bond rate. Right? There's a lot that you would want to consider for your validator subsystem, and then even more for your liquidity provider subsystem. So here I list a couple of variables like settlement token price in Rowan, and your swap volume, your number of unique liquidity providers. But you can imagine, even more, which I'd say are things like number of different tokens available across liquidity pools for multi-pool systems like a bouncer, and so on and so on. And so then there are other variables. So for SiftChain, we actually use pegged tokens. And so the pegged token providers need to have some kind of fee, a service rate is what we call it, to manage the bridge. So you can imagine something like TBTC, like the Keep network, where a fee is paid to anyone who mints a token. But there's but in exchange, you've got a decentralized peg. And so for something like that, that actually is an exogenous variable in the system, but it does impact the crypto-economic system. It's actually now a third sort of tool that you can use with your revenue. And so between validating in the main system and providing liquidity, you can also validate in the peg system, which is another thing to consider. There's liquidity mining. SiftChain will have its own liquidity mining program. And that'll affect things. We've actually made sure that the validators and the liquidity providers both get liquidity mining rewards because we need to make sure that the rewards given to the two agents in the subsystems are relatively equivalent. And then there are other cryptocurrency ecosystems. So we're seeing a lot of issues with composability in the Ethereum space, where the actions of one blockchain or one cryptocurrency ecosystem can have a substantial impact on others. We've seen, to some extent, that happening with something like FTT and some of the tokens that have been using it as collateral. We've also seen that with, say, Wi-Fi, which does liquidity mining on a variety of other Ethereum systems. And so you'd imagine if you were a sophisticated crypto-economic planner, you would make sure that your crypto-economic system is setting this F as a function of what other cryptocurrency ecosystems do, so that you can hit a lot of corner cases. So again, a lot of stuff to decide. How are we going to decide it? Well, let me just okay. So the answer for us is on-chain governance. So we've seen quite a few projects try to create this function F based on a hunch that we think is worth exploring, but does not necessarily require a new token. And this did make sense as the cryptocurrency industry was still growing, and DeFi in particular was developing. But we feel like a lot of the next generation protocols are going to consider a lot of variables that haven't been fully explored. So number of unique wallet addresses is one thing we mentioned here. There's also trailing average volume. And you can imagine that over various time periods, like 3 days versus 10 days versus 21 days and so forth. There's also liquidity to swap volume ratio. We've seen a lot of protocols launch with really great liquidity mining programs and thus have really solid liquidity that's available, but not as much swap volume occur. I think this happened for like the first day or two of SushiSwap. And so I feel like the AMM formula should be dynamic with respect to a lot of these figures. One thing I would point out here is that this could even mean that two different pools on the same chain have different AMM formulas. There's no reason that the fee on, say, a Uniswap needs to be exactly 0.3% for a really high trafficked pair like ETH and USDT as it is for ETH and some really small token that's just launching. In fact, liquidity mining is really a cryptocurrency ecosystem's way, like a particular team's way of changing that fee by providing some additional value to liquidity providers in exchange for providing liquidity for that particular token. Some programs even give rewards to swappers as well. So we really don't think that it necessarily should be the same. It should definitely be something like a function of, say, the total amount of wallets and trailing volume. But beyond that, it's really there's this idea that these markets really change dynamics as they gain trading volume. If you talk to any sophisticated market maker, they'll tell you that the strategies they use on a cryptocurrency market with, say, $500,000 of daily trading volume is very different from one with $2 million, which is different from one with like 20 million, and then different from one with 100 million. The number of market makers themselves who will participate is actually different. And the kinds of strategies they deploy, as I mentioned, will be different. So we think that automated market makers should adopt the same style. We also think that these formulas may need to change over time. So the same liquidity pool may have different AMM models between, say, one epoch of time over the next. This could be because they have new they've like substantially changed in volume, but it could also be for some other reason, like because the governance of SiftChain or the governance of SiftChain that is focused on that particular pool wants to try some experiment or something else that's new. So we really feel like the SiftChain core team is responsible for building a robust platform that makes it easy for data scientists or protocol politicians to run experiments and submit proposals for changes to this function. On-chain governance is responsible for observing the effects that this function has on key metrics like liquidity provider revenue and row on token price, and then encouraging new proposals to optimize these metrics. And that, I'd say, is really the cycle that you can expect for governance to ultimately nail this over time. So that's it. I was imagining I might take some questions, but I believe that's not the format. So you can all just look at this really beautiful picture. And I hope you enjoy the rest of MoneyDance.